Mars has two relatively small, compared to Earth's, natural moons. Phobos, about 22 kilometers, 14 miles, in diameter, and Deimos, about 12 kilometers, 5 miles, in diameter, which orbit close to the planet. The origin of both moons is unclear, although a popular theory states that they were asteroids captured into Martian orbit. Both satellites were discovered in 1877 by Asaph Hall and were named after the characters Phobos, the deity of panic and fear, and Deimos, the deity of terror and dread, twins from Greek mythology who accompanied their father Ares, god of war, into battle. Mars was the Roman equivalent to Ares. In modern Greek, the planet retains its ancient name Ares, 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 from the surface of Mars. The motions of Phobos and Deimos appear different from that of the Earth's satellite. The Moon, Phobos, rises in the west, sets in the east, and rises again in just 11 hours. Deimos, being only just outside synchronous orbit, where the orbital period would match the planet's period of rotation, rises as expected in the east, but slowly. Because the orbit of Phobos is below synchronous altitude, tidal forces from Mars are gradually lowering its orbit. In about 50 million years, it could either crash into Mars' surface or break up into a ring structure around the planet. The origin of the two satellites is not well understood. Their low albedo and carbonaceous chondrite composition have been regarded as similar to asteroids, supporting a capture theory. The unstable orbit of Phobos would seem to point toward a relatively recent capture. But both have circular orbits near the equator that is unusual for captured objects, and the required capture dynamics are complex. Accretion early in the history of Mars is plausible, but would not account for a composition resembling asteroids rather than Mars itself. If that is confirmed, Mars may have yet undiscovered moons, smaller than 50 to 100 meters, 160 to 330 feet, in diameter, and a dust ring is predicted to exist between Phobos and Deimos. A third possibility for their origin as satellites of Mars is the involvement of a third body or a type of impact disruption. More recent lines of evidence for Phobos having a highly porous interior and suggesting a composition containing mainly phyllosilicates and other minerals known from Mars point toward an origin of Phobos from material ejected by an impact on Mars that reaccreted in Martian orbit, similar to the prevailing theory for the origin of Earth's satellite. Although the visible and near-infrared (VNIR) spectra of the moons of Mars resemble those of outer belt asteroids, the thermal infrared spectra of Phobos are reported to be inconsistent with chondrites of any class. It is also possible that Phobos and Deimos are fragments of an older moon, formed by debris from a large impact on Mars, and then destroyed by a more recent impact upon the satellite.